Graphing systems of equations. The objective is to solve a system of equation by graphing, and also identifying the type of system. There's lots of Algebra 1 standards involved with this, so this is a pretty important lesson. So Algebra 1, 2, 3, 4, 1, 5, 1, 5, 6, 9, 1, and 9, 8. So a system of equations. By definition, two or more equations with the same variables. The variables stand for the same thing then, and that's what makes it a system of equations, okay? It's two or more equations with the same variables. As you go on in math, there's going to be more than two. We're just going to concentrate on two mainly, but could be 3, 4, and so on, and that kind of puts more constraints on it. But we're just dealing with two. The solution is the point or points that satisfy all equations. Now, what that really means, the points of intersection. That's the solution. Where the lines cross over each other, that would be considered the solution. Now, three things can happen with this involving two lines. So here are the three possibilities, and it's going to be important that you remember which part goes with which possibility. So first of all, the most typical when you have two lines is they cross over into one intersection. They have one solution. Okay, so the answer on that would be definitely an ordered pair, and you would list the ordered pair x, y. Okay, the actual numbers, that's your solution. But you also have to know this terminology. Then if it has one solution, it is consistent. Consistent means that it has a solution. Independent means it has just one solution. Okay, so it is consistent because it has a solution, and independent because it's just one. The next possibility is where the two lines are parallel, and if they're parallel, they're never going to intersect, so there is definitely no solution. If there's no solution, then it's considered inconsistent. Then there's no dependent or independent at all. It's just flat out inconsistent. Okay, so dependent, independent only applies if there is a solution. Inconsistent, no solution at all. Okay, so maybe you can think no solution, it's not normal, so it's inconsistent, something like that. Okay, then finally, the last possibility, if the two equations would happen to be the same line. And, you know, when they're given to you, they're not going to be given to you the same right off the bat. They're going to look different. But if you go and try to simplify it, maybe put it in slope-intercept form or something, you're going to see they're the same line. In that case, there are infinitely many solutions. You may write IMS. Infinitely many just means that all those points on the line, and the lines continue on to infinity, right? Those are all solutions, so infinitely many solutions. In that case, since they have a solution, it's consistent, but because there's infinitely many, it's now dependent. Okay, so consistent, inconsistent. Consistent has a solution, inconsistent, no solution. Independent, dependent. Dependent, one depends upon the other. It's completely the same line. That's many solutions dependent. Independent is normal, where it has one intersection. I say normal because it's the most often occurring, okay, where they intersect in one point. So most of the time, it's going to be consistent and independent. So you'll have to know that terminology, okay? Know it for a quiz, know it for a test, and so on. All right, questions about any of that? So let's look at, use the graph below to determine if the system is consistent, inconsistent, dependent, or independent. If it has a solution, name it. So this graph is similar to something you might have in a homework or on the quiz. There's lines already graphed, and I hope you can read this. It's kind of hard for me actually to see it, so maybe it's kind of hard for you. I don't know. This line is y equals negative x plus 4. This one down here is y equals negative x plus 1. This one, a little bit easier to read, y equals x minus 3. And this one, 2x plus 2y equals, I think it says 6. Now, do you see something about these two right here? What's interesting about those, Maitri? It's the same line. So, if, like I said, they don't give them to you the same to begin with. So if you went and put that equation right there in slope-intercept form, you'd get y equals x minus 3. So, just saying. What's that?
Is it 2x plus?
I think it said 2x, was it 2x minus 2y?
Yeah.
Okay, 2x minus 2y equals 6. Okay. Now, oh yeah, it's written down there. So, oh, I see. They've got them all over here. Huh. That was probably because I couldn't read them on the graph. All right, so example A, it's got y equals negative x plus 1, so this one, paired with y equals x minus 3, this one. All right, so let me erase this circle too so that helps us a little bit. There's a lot on there. Okay, so these two, do they intersect in one solution, no solution, or infinitely many solutions? Josh? One solution. So since there is one solution, since there is a solution at all, consistent or inconsistent? So definitely consistent. One solution, is it independent or dependent? Independent. And we need to name the solution. It would be this point right here, and it looks like 2, negative 1. All right, so y equals negative x plus 1, so this one here. And y equals negative x plus 4, so this one right here. Do they intersect in one solution, no solution, infinitely many? No solution. So since it's no solution for this one, then is it consistent or inconsistent? Inconsistent. And when it is inconsistent, you don't worry about independent or dependent. And your solution is no solution. All right, now let's look at this example. It says y equals x minus 3, which is this line, and then 2x minus 2y equals 6, which is this line. So what's that tell us? What do we say about that? Infinitely many solutions. So is it consistent or inconsistent? Yeah, that one's consistent. And since it's IMS, infinitely many solutions, is it independent or dependent? Dependent. So that's what you're going to have to do. You're going to have to look at sets of lines together that are already done and make a decision about their intersection. 1 point, no points, or infinitely many, and then decide consistent, inconsistent based on that information. Questions about that? Zach? No question? All right. Anybody else? Ethan?
Why aren't we writing like one solution, no solution, or IMS?
Because you write what it actually is. Those words that I gave you is telling you those are the possibilities. There could be one, but all the time, usually when there is one, you tell what it actually is, okay? Or this empty set is saying no solution, and then IMS is saying infinitely many solutions, okay? Anybody else? Now, there's also going to be some where you have to actually graph, and I'm going to tell you the truth. Solving systems, in my opinion, graphing is the least accurate method to find a solution, okay? Now, since I'm not the boss of the world, that doesn't matter that I feel that way. It still has to be done. You still have it for your 8th grade I-STEP. You still have it for if you ever had to do an ECA or an algebra test. They're going to have you graph a system and solve it. That being said, I'm going to tell you, it's never been more important for you to use a straight edge and to be very careful with your lines, because one little mess up and your point is going to be off track. The other thing is, if your point doesn't end up on an exact corner, how do you know where it actually hits, right? By graphing? If it's a fraction, how do you know what that is? So I'm not a fan of this, but it's still something we have to do. I'm hoping the ones that you have to do will hit as close to a corner and you can kind of tell what it is. I know that this one for sure does. So let's go ahead and do it. So y equals 2x minus 3. So we'll go through the steps of graphing. You start out at the y-intercept, so that would be a point down here at -3. And the slope being 2, remember I put 2 over 1, so rise 2, run 1. Honestly, I would do as many of those as you can. Rise 2, run 1, rise 2, and just go fill out the whole graph if you can. And maybe even fall 2 and go 1 to the left, because the more points you have, the more accurate your line's going to be. Now, I have a line tool on here that I'm going to use, or else I would definitely say you have to use a straight edge. Okay, there's no way around that. So there's one. The next one, y equals -x plus 3, means I would start out at +3. And -1 for the slope means fall 1, run 1. So it would be here, 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 here. But I think, thank goodness, we found our point, and that's when it's good to know that you can also rise 1 and go left 1. So when I graph that line, okay, and I think we have found that the intersection point would be this right here, which is 2, 1. Thank heavens it was easy to, and it fell on a corner. And if there is a solution, is it consistent or inconsistent? So you would say consistent. And if there is one solution, is it dependent or independent? Independent. Okay, questions about that? Okay.